Okay, students, this is the third page, or rather the right side of the back half of your review. Okay, it says testing to exam review at the top, and it starts off with, are these functions even, odd, or neither? Okay, so this is an algebraic function, so we have to use algebraic reasoning. So we are testing these two functions. Okay. First, we test our f of negative x. We replace x with negative x, and we compare it to the original. If those two things are the same, then your function is even. If they're not, then you make the entire equation negative, and we compare those ones. If those ones are the same, your function is odd. Now, if no three of those look alike, then your function is neither even nor odd. So let's try it. Let's do it and see if it is even. Okay, so the first thing we always test is for even f of negative x, which means we replace x with negative x everywhere we see an x in your original equation. Okay, so we're putting x here and we're putting x there. Now, some things you need to remember. If you square, or rather raise a negative to an even power, anytime you raise a negative to an even power, the answer is always a positive. Okay, a negative raised to an even power gives you a positive. So negative x raised to the sixth power is the same as normal x raised to the sixth power. Okay, likewise, for our negative x raised to the second power, right? A second is even number. So a negative x raised to the second power is the same as raising it normal x to the second power. So now we compare. How do these two equations compare? Well, hopefully you see, after I erase this stuff that I wrote there before, that these equations are the exact same. 3x to the sixth power minus 5x squared. That means that number one is an even function, because it follows that those two are the same. Even. Okay, let's look at the second one here. Let's first test for even. What happens when I replace x with negative x? I get 4 over negative x, okay, which is not the same as your original, okay, which is 4 over positive x. So in other words, this is not even because those two are not the same. So now we test for the second one. What if we make the entire equation negative? Okay, so you go back to the original, right? The original was 4 over x, and you put a negative in front of the entire thing. Put the entire equation in parentheses, and then we simplify. Well, there's really nothing to simplify except for take away the parentheses, and then we compare these two. How does f of negative x compare to negative f of x? Okay, and hopefully you see that they're the same, so that means this one is going to be an odd function. So number 2 is odd, because it behaves in the fact that if you change the x to a negative, that's the same thing as making your entire equation negative. Okay, one more. First, we test for even, so we replace x with negative x. So 4 times negative x to the fifth minus 2 times negative x. Okay? So a negative raised to an odd power will always be a negative. So we can take the negative from the x and put it in front of your coefficient, because the whole entire term is going to be negative. And then, of course, a negative times a negative is a positive. 2x is the second term. So comparing to our original, notice that they are not the same, so this is not an even function. So the second thing we do, since it's not even, is we make the entire equation negative. Put a negative in front of everything, so negative of 4x to the fifth minus 2x. Okay, and distribute in the negative, and we find out that that's negative 4x to the fifth plus 2x. Right? So now we compare the red equation to your blue equation. Seeing that they're the exact same thing, we can say that number 3 is also an odd function. Okay, so we're using the algebraic definition of even and odd when we're given an algebraic equation. Right? We're testing to see whether replacing x with a negative is the same thing as what you started with, or if it's the same as making the entire thing negative. Here we have an expression for f, right, this equation. And I'm told that there's some g that's 2 times f of x minus 1. Okay, so this is just some algebraic substitution. First, we want to replace x with x minus 1. So everywhere we see an x, you put an x minus 1 instead. And then you take that entire function and multiply it by 2. Okay, so that's what it's telling us to do. The 2 in front says multiply by 2, and the x minus 1 inside says replace x with x minus 1. So now it's just a matter of simplifying and writing down the answer. Right? No solving. We just want an equation for the answer. So there is all of that mathematical simplification. Right? The first step is the pre-calculus, identifying what your transformations are doing to your problem. Right? We are moving the x 1 unit to the right, so we are adding 1 to the x. Right? So we're replacing x with x minus 1, and you're multiplying the y values by 2 to get this as your answer. Okay? So that's what we got for these next two, right? These are algebraic, looking for compositions. So in a composition, you are taking an equation and you're replacing the variable in the other one. So g of f takes the f equation and plugs it into the g function. So we have x squared minus 3x plus 7 plus 2. Right, so we replace x with that entire quadratic from f, and we are adding 2. Okay, which doesn't take a whole lot to simplify because there aren't many like terms. And then since this is not factorable, that's your answer. There's nothing else to do in order to identify the function that we're calling h. Okay, calling that h. Now, similarly for number 14, you want to take the g and plug it into your f equation in 2 different places. So we replace x here. That's a 3 in front, not a 2 in front. We're going to square that, plus 5 times 2 over x. Okay, so squaring, of course, means multiplying it by itself. 2 over x squared is 4 over x squared. Okay, plus 10 over x, because when you multiply a fraction times a non-fraction, you only multiply the tops. You don't multiply the bottoms. So our last step would be to multiply 3 times 4, get 12 over x squared equals, plus 10 over x. Okay, so there's not a whole heck of a lot you could do to that. I guess we could write it as 12 times 1 over x squared maybe, plus 10 times 1 over x, but I don't know if that's any simpler, so I think this one would be sufficient. Okay, so some algebraic things that you need to know how to do, right? Just substitution and simplifying, substituting and simplifying. So lastly, number 15. Here we have your piecewise equation, or your absolute value equation. Okay, and we want to write it as a piecewise without absolute value bars. Right? So we're going to have a piecewise equation that happens to have a linear over a linear. Right? Always we're going to have a linear equation when you are having a piecewise. Right? Piecewise graph to v's normally. and the v has two parts of the line. So the first thing we're going to do is we're going to find out where is that fence, right? Where is your domain restriction, your constraints. Okay, so this is what we did in class, and it was pretty okay when you did it, and then we freaked out when you went home and tried it on your own. So step number 1, solve your absolute value. Okay, number 1, solve this. What is x minus 2 equals 0? What number minus 2 equals 0? X equals 2. Okay, so what this does is we have found the constraints. We have found the line that separates your v from the left side and the right side. So what we did in class when we were writing this is we put this number on a number line. Positive 2 went there, right? And you made 2 halves. So you have an equation on the left half of positive 2, and we have an equation for the right half of positive 2. Okay, and what we did is we took your absolute value equation and we wrote it without any absolute value bars. Right? So we took away the absolute value bars and we put in parentheses the entire equation. Right? So our job was to decide, do we make this thing a positive value or a negative value? Okay, do we make the absolute value part positive or negative? And that was the next step in figuring this out. And how we did that was we picked a number to the left of 2 and we picked a number to the right of 2. And we plugged it into this, right? This is the absolute value part. We plugged it into that equation, right? Just the absolute value part. Nothing on the outside of the absolute value, nothing after or before. It went into just that part. So we do 0 minus 2 equals negative 2. Okay, so negative 2 tells us that the sign of our first equation on the left side of positive 2 is going to have a negative in front of it. Okay, there's going to be a negative in front of that equation. And if you plug in 3 minus 2 is positive 1. So this one's going to have a positive in front of it. In other words, that part doesn't change at all. Right, so if you have a negative, that means we're going to change the sign of your equation. And if there's a plus, that means the sign doesn't change, right? It stays exactly what it is. So with this knowledge, now we can simplify your equation. So x minus 2 plus 5 gives me an equation of x plus 3. Here we're going to distribute the negative, so we get a negative x and a plus 2. So our other equation is negative x plus 7. Wait, teacher, it says positive. So let's come to write our equation. Okay? So I know there's not much room on your paper, but we're going to write it right here. So we put in your mustaches, right? Your mustaches. So we have G. The name of our graph is G. G of x equals. Okay? The one on the left, so the x plus 3, this is the one that's going to go on top of your, right, because we have a top and a bottom. It's going to go in this space. This is going to be the x plus 3 equation. And the one on the right side of positive 2, your negative x plus 7, is going to go on the bottom spot. Okay? So when you literally make your 2, everything to the left of the 2 is the top equation, and everything to the right of the 2 is the bottom equation. Okay? And if we had 2 of them, then we'd have a middle section, and that would be the middle equation. Okay? So now we're just missing the constraint. And that constraint was when x was less than 2, right? To the left of 2, we had x plus 3 as your answer. And if you went to the right of 2, we had negative x plus 7 as the answer. Okay, so your absolute value needs to have, your piecewise needs to have an equation and a constraint. Okay, it needs to have both of those pieces or it is not correct. It needs to have this part for both of them. And you can have less than or equal to's. Okay, they can both be or equal to. Now the last part says, let's graph this. So thinking about our transformations, let's think about what our transformations, these things, do to our absolute value graph. So the x minus 2 moves our graph right 2 units, and the plus 5 moves your graph up 5. So from your vertex, we go right 2 and up 5. From the origin, this is going to be the vertex of my absolute value. And then what does the negative in front do to my graph? Right? It reflects it across the x-axis. In other words, this opens down, right? Our V is not going to be an upward V, but rather a downward V. So you do a negative 1, a 1 slope, right? It hits all the 45 degrees, every corner. Make sure it goes through every corner all the way off the grid. Right? Don't just draw any crazy crappy line there. Make sure that you are being careful and you are making it look as good as you look. So there is your graph. Now let's see. This slope here is a positive 1 slope, and it crosses your y-axis at positive 3, okay, which is exactly the equation that we wrote, right? Positive 1 slope crosses at 3. This was an equation of x plus 3. And this side was an equation of negative x plus 7. So it has a negative 1 slope, sure enough, down 1, right 1. And if we were to continue, we would see that this line crosses at positive 7, which means that we did it correct. We have our equation written correctly. We did the math correctly. Everything works out wonderfully well because your graph matches up with your equations, right? Those algebra 1 things. So this is the last page. If you need assistance, of course, I tutor every morning. So I'll see you in my room if you need